where the time is 9:45 tomorrow morning. And the topic of my presentation is 64-bit VFP development. A little bit about myself. I trained in medicine, stepped aside from clinical practice in '92 to go and develop some software for myself and my surgical colleagues. Never quite went back. I've been using Fox since the 80s. I began using VFP C++ compiler and then VFPA since 2009. And I've been using first the compiler and then VFPA in commercial applications for well over 10 years, 13 years. Agenda: 64-bit development in VFP. How, why, when, more how, Murphy's Law, which is what can go wrong, will go wrong, and then any questions. So, 64-bit VFP development. How? VFP is a 32-bit product, and as we know, 32-bit products can't access 64-bit resources or vice versa. So there is only one way to do 64-bit development in VFP, and that's using the VFPA x64 add-on from VFPA software. Apologies if I massacred that pronunciation. Now, the VFPA add-on is an add-on. It's not an alternative product. You have to have VFP9 installed on your machine in order for VFPA to be installed, because it actually patches VFP9. It delivers bug fixes, enhancements, and interoperability improvements. But importantly, it doesn't affect your VFP9 installation. It creates a separate VFPA launch folder. So that means you can have this VFPA and VFP9 on your machine at the same time, just as we used to with VFP 6, 7, 9, whatever. So there's no reason why you couldn't have a play with VFPA x64, since it's not going to damage your existing VFP. VFPA software principal Chen Shuabing, Mr. Chen, a long-time VFP user, began developing the compiler in 2008 and VFPA in 2012. My association is purely paying customer and very impressed by the work Mr. Chen does. So still looking at how, if you want to use VFPA x64, you simply download and install the VFPA x64 add-on and start opening your project and see what runs. Now, this audience does not need to be shown how to install a product, but I'm just going to briefly run over a few things to try and save people a bit of grief. If we look at the VFPA software download site, obviously you click the VFPA or VFP Advanced x64-bit version and you download it, you unarchive it, and you install it. A couple of things to note. This is the 2022 version. The current up-to-date version is April 2025. So if you like what you see and want to use the very latest features, you should register with VFPA software, and then you start to get emails with release notes and a different download link which contains the latest version. The other consideration is that if people think that 64-bit is a minority interest in VFP, the 64-bit version has been downloaded from here almost 50,000 times, and that doesn't include those of us who are registered users. So you're not alone. Okay, if we just go across to this documents page, I mentioned VFPA brings bug fixes, enhancements, and interoperability improvements. As of May 2025, there are 377 fixes and improvements, and notably, a lot of these are happening after 2022. So that one's June 2022, but a lot of them are happening after that. So if you want to utilize all the latest features, you probably need to register and get the most recent version. All right. When you download and install and unarchive it, this is what the installation looks like. You can see there's an executable, a DLL, and what's this? A readme first !.txt. Again, I'm not going to belabor this, but in the past, people have had huge problems getting VFPA installed because they don't have the correct version of VFP9. As an add-on, VFPA has to patch things in your VFP9 install, so if it's the wrong version, it doesn't patch correctly. So if we look here, these are Sentinel files that tell VFPA you've got the correct version. Two of them are the 5815 version, which are delivered by Service Pack 2, and these other ones are the 7423 version, which is the hotfix 3. So if your VFP has got Service Pack 2 followed by hotfix 3, you have a version of VFP which the installer can easily patch. Where to get these from? Well, Microsoft doesn't supply them anymore, but they're available at the VFPX website, or there are links here which directs us to that same download page we were just looking at, where you can get the 5815 and the 7423 versions. Now, sometimes people are concerned that they might be getting something which is not authorized, but interestingly, Microsoft saw fit to sign both of these service packs, but they didn't sign the content, which is a shame. We'll come back to that. So it doesn't matter where you download them from. If they're signed by Microsoft, they have not been interfered with. So you want to get those and you want to install it. What I'll do is I'll just, again, don't want to belabor the obvious with this audience. When you run the setup, first thing is it's also signed. And there's a reason why I'm making a big song and dance about digital signatures. In the x64 world, they expect everything to be signed. In modern development, we expect everything to be signed. In the VFP world, nothing was signed. And that's becoming a problem. We'll get back to that. But this is signed. This is the official release from VFPA software. This is a color scheme that will become very familiar to VFPA software customers. Notably, this is going into program files, which you'd expect for a 64-bit product. Now, I know a lot of you guys will have stopped installing to program files because VFP9 was not a good corporate citizen under UAC. The deficiencies which caused that decision have been fixed in VFPA, so it no longer defaults to saving your configuration files into the launch folder, which is a no-no under program files. It puts them into an app data folder, as it should. It automatically compiles the PRGs that VFP used to try to compile at runtime. So you can register your product under program files, which I have done, and it works perfectly well. That's just something to note. If you have installed your VFP into C:\VFP9, actually the installer is smart enough to find it there, and it'll offer to install your VFPA to a similarly named installation if you want it to. Look up what these mean. MSVCR 100 is the VC++ 10 runtime. The first VC++ that offered 64-bit compilation was version 10, and all of these runtimes are signed. So hopefully you can get a flavor straight away for the fact that you're moving into a modern signed era when you make this move. The only one I will focus on is that one. That's on by default, but if you turn it off, then this installer will not register VFPA x64 as the default VFP on your machine. So you'll recall in the old days, whichever VFP you installed last made itself the default VFP. This installer does the same, but if you turn that off, it won't. So just turn that off, run install, and because you've got the correct version of VFP9, VFPA will install nicely on your machine. So if we pretend we've done that, on my machine, I have VFPA. I don't know whether you can see down the bottom. VFP Advanced. I have VFP 9, and I have VFPA X64. I've actually also got VFPA X64 version 10.1. If we get time, I'll show you why. But if I click that fella, as you'd expect, up comes VFPA X64. How can you tell? Well, the title bar tells you. And in your development, there's a new system variable called Win64. So if you're running x64, that's true. If you're running VFPA x86 or 32-bit, that's false. And if you're running VFP9, the system variable doesn't exist. So that's quite a good way to tell which one you're running. The other good way is sys17. Under both VFPA and VFP9, that returns, helpfully, the word Pentium, whereas under x64, it returns x64 AMD or Intel. So should you need in your header files or in your programs to determine which version you're running for whatever reason, that's how you do it. Now, I can go through and show you a whole lot of features, but if we just briefly pop back to my presentation and just go from the current slide, why would you do it? Why would you want to move to x64? And the standard answer is that x64 is better, bolder, brighter, bigger, faster, stronger, and more super duper in every way. So I'm not going to belabor these things. You get the idea. x86 under Windows can only access 3.2 gigs of RAM, whereas under x64, technically it can address up to into the exabyte range, although the Windows limit cuts in long before you reach that level. And of course, x64 has wider registers and more of them, and the wider register allows it to address more memory, but also to transmit and process data a lot quicker. And the other interesting thing about the x64 architecture is it actually includes the entire x86 instruction set. So it supports both 64 and 32-bit, whereas x86, of course, cannot support 64-bit architecture. Why is the performance quicker? I've put this example here because in VFP terms, x86 is a little bit like calling a function and passing variables by a value. So the function receives the values, puts them into its own variables, works on them, and then discards them. Whereas x64 is like having variables already in scope. And when you call the function, it simply uses those variables, which is measurably quicker. So you can go and have a look at this if you want to. This is pushing values onto the memory stack, which is a very common x86 way of passing wide values, whereas x64 has already got wide values, simply loads them into the one of the general purpose registers, doesn't use the stack. And the general purpose register is a bit like an incredibly fast public variable that's accessible everywhere. So you get the flavor for why this should be quicker. Now, it says there the proof of the pudding is in the eating. Basically, let's try it. I'm going to go into VFP9. Okay. I'm going to modify a prepared program that I've got, which demonstrates a very simple but indicative piece of code, simple loop. So what this piece of code does is it clears the screen, and then for 1,000 times, it prints a counter and then tells you how long it took. I'm just going to run that. So that took 1.9 seconds. Okay. If I now go into VFP X64 and modify the same file, I'll just grab that. Okay, it took about the same amount of time. Now, often the X64 will be quicker, but not always. And my experience is that for simple VFP functions, the X64 version is sometimes slightly quicker. But to my mind, actually Windows has more of an impact on the performance than the X64 versus x86 architecture. So performance has been gradually improving in the X64 version, and some people swear that their X64 products work quicker. What I would say is they're certainly not slower. They could be. In other environments, X64 is said to run slower. And one of the reasons that VFPA X64 doesn't run slower is that it's using the very modern RIP relative addressing. You can go and look it up if you're interested. It basically means that rather than jumping to full 64-bit registers, it's an inbuilt hardware mechanism to jump relative to the instruction pointer. So you get very compact portable code. Okay, but just carrying on with the bigger, bolder, stronger theory, VFP9's maximum string length is about 16 meg. VFPA is 268 meg. Mr. Chen has said in the past that the way he changed that was by simply patching a D word in the executable and in the runtimes, which suggests that this 16 meg limit has nothing to do with architecture. It was just a decision made back probably in the VFP3 era when machines had far less resources, and it never got updated, but it is now. Whereas now VFPA 10.2, which is a very recent edition of VFPA, can technically address more memory than you can get onto a Windows machine. I'm not going to focus on that. If you think you need that much memory, you can register with Bayesian software and see how it's done. Then, of course, there's DBF size. Using VFPA 10.1, tables can be into the terabyte range. But the reality is that few machines have hard drives big enough to make use of this. And I think many VFP users would say that if your data is approaching 2 gigabytes, let alone a terabyte, you should have it into SQL Server anyway. So some people may regard these things as trick shots. I've covered that a little bit in the white paper if you want to go and have a look. There's another reason why. VFP9 has got a significant perception problem. Now, this is the OWASP top 10 risk list. OWASP is an international consortium which focuses on development risks. And what you can see is they produce a list every few years. There's actually one overdue. There's meant to be a version in March 2025. It's late. But between 2017 and 2021, you can see that using components with known vulnerabilities at position 9 moved up to position 6. It's now called vulnerable and outdated components. And when you look at the definition of that risk, VFP scores hat tricks. It's using obsolete, unsupported runtimes, both Visual C++ and VFP9 itself, and nothing is signed. So that is a significant perception problem. And this is not a theoretical risk. This is from one of the VFP bulletin boards. People here will recognize which one straight away, but I've done my best to anonymize. This is from last month, a few weeks ago. The gist is that this developer has a long-standing 25-year customer relationship, and and the customer has been asked for a security and vulnerability certification, which failed because the auditing company says the software can't be considered safe because it's written in obsolete language. In response to this experience came this. So this time, it's somebody trying to integrate with the Gmail API for a business application. And Google's head of security and trust says he is not going to proceed with the review because VFP9 breaches the requirement that developers have to be using supported and up-to-date packages and libraries. So they didn't even perform the assessment, and this person was unable to access the Google API. Now, moving to x64 is not a magic bullet to prevent that, but x64 is automatically regarded as more recent and more supported than x86. And as I mentioned earlier, it's coming with signed Microsoft dependencies like the VC++ runtime. There's other things. We know that VFP9 wasn't a particularly good UAC corporate citizen, but Microsoft has been installing additional security features. So DEP, data execution protection, basically means that chunks of memory are defined as non-executable if they only contain data. So that includes things like stacks and heaps. And it means that a hacker cannot cause a buffer overrun or sneak a bit of instruction code into a memory variable and then trick the application into running it. So it's quite a good protection mechanism. And ASLR basically means that whereas back in the VC++ 6 days, it was regarded as best practice for DLLs to have a defined base address, we figured out that it's not a good idea to tell a hacker exactly where to look for important structures. And ASLR basically randomizes the base address of a DLL, which means a hacker can no longer easily guess where to find things. Bottom line is VFP9 is not compliant. Now, x64s are DEP compliant by default, and most of them are ASLR compliant. So you're starting to get the flavor, hopefully, that the mere fact of distributing x64 product or even the option of x64 product carries a flavor of modernity. And these sorts of things are frequent boilerplate security audit checklists. Why not take the easy win? When any auditor sees you're getting these ticks, they begin to lose value. And it's been suggested to me with some merit, I think, that we should not be distributing VFP9 applications in 2025. That's a bit scary. There are mitigations you can use. If people ask in the answer section afterwards, happy to go into it, but don't want to stop and do it now. So we're back to how. So what I would say to you is that native VFP functionality is 100% compatible between x64 and x86. That's been verified by a large number of users. And I've got some slides coming up that we'll go into shortly. But everything from your DBF database, including large files, you can access large files in VFP9 because the large table mechanism doesn't actually change the structure. So that doesn't change. It's totally compatible across versions. But ActiveXs are also compatible between x64 and x86. It had been suggested that you would need different versions of x86 and x64. It's not the case. And the big bugbear is FLLs. So let me just show you this. If it's something that you'd expect to test the VFP x64 would be something like word automation. So it'll be familiar to many developers here. I've just created a word automation object. But get a load of this. So Word should now be visible. There it is. And because this is a modern Windows application, rather than help about, to find about, you go into Account, About Word. So VFP x64 has created a 32-bit automation object. How could that be if x86 can't access x64 and vice versa? Well, this is one of these limitations that it's a bit like saying I don't go through red lights except when I do. x64 can't access x86 resources except when it can. Now, unfortunately, that's not quite as useful as you might hope. Let's look at some more examples. ActiveX controls. Okay, we're in the x64 version. I have just opened a VFP form which has got an embedded web browser control. In the init of the web browser control, it has got navigation to, I've just changed it to Google. I'm running it in x64 and everything works as you'd expect. So the good news is the web browser control was the very first ActiveX control confirmed to work in VFPA x64 all the way back in 2014, over 10 years ago. So you can confidently utilize this control in your work. And just as a reminder, because many of us won't have done it for a while, the way to make sure ActiveX controls show up is Options, Controls, select ActiveX, and make sure it's checked in your implementation. Microsoft Web Browser will appear there without you having to do anything. This one won't. The TreeView. We'll come back to that. Okay, so that's running an x64, and just to confirm, back into x86. Same form. There you go. I'm going to pretend I did that on purpose so you'd know it was the same form. Right, try that again. Same form, run it. So that's exactly the same form working in x86 and x64, which means you can develop forms with the web browser and compile them as you please. Right, if only it were so simple. If you look at this GUI, you might agree with me that it looks a bit clunky by modern standards. And if we go into Edge, same machine, same URL. From Edge, it's got About, Store, and a nice, I think that's a bootstrap entry box. Web browser controls got an old clunky version, and I think most people here will know why. The web browser control is using the old IE Trident engine. And not only that, by default, it's using a very old version of IE, IE7, I think, from memory. So when you go to a website like Google, it detects an old clunky browser and delivers an old clunky version. But there's a bigger problem, which is that now that Microsoft has deprecated IE, sites no longer bother to check for it, and the Trident engine is not compatible with the newest ES6 version of JavaScript. So if I go in here and start typing, so basically the engine is not capable of rendering that page compared to the Edge engine, which does as you'd expect. And this is now a problem. I didn't do it. Sometimes you can get a huge number of error cascades happening. Aren't we lucky? So I'm now going to talk about the availability of Microsoft x64 ActiveX controls. My impression is they only exist at all because Access developers needed them. So a lot of Access developers, it appears, like to use the web browser control to embed Google Maps and other things into their applications. And therefore, an x64 version was needed to accompany the move to x64 Access. And I think that's why it's there. But then this happened. If we change that to maps.google.com, I actually won't do it because it causes a huge cascade of script errors, which takes time. But the gist is that you get an incompatibility page and get told to update your browser, and it feels like hundreds of scripting errors you have to press escape for. So as you can imagine, the Access developers complained, and Microsoft then released a new version of this web browser control called the modern web browser control. So obviously you can see what I'm coming to. A good path forward for VFP people who have been using the web browser might be to move to the modern web browser, except that if we go to this page here, now this is the blog page for probably the foremost blogger regarding all things Access browser related. And it describes a litany of problems with the modern web browser control to the point where which one is best. If none of the bugs existed, you could argue for it. If you need free navigation, you need to render local files, you need to allow mixed content of local and web content, you need to navigate your local storage system, and you control the HTML so it's compatible with the Trident engine, then the old web browser is better. So I have not bothered to look at the modern web browser control. If you have a look, it's full of mistakes. So I think the best advice for someone who has been doing this for a while is keep using the web browser control, which, as you can see, works the same in x64 and x86. Now, Microsoft says that the underlying MS HTML engine is supported until at least 2029. So you've got some time. And they've also promised a full year's notice of any intended deprecation. So for now, if you need a web browser control, you can keep using the web browser control. If you look in the paper, there are freeware and commercial alternatives. There's even a VFP version written by Christoph, who's one of the presenters at this conference, but it is x86 only. And there's a free one from the VB community, which is x86 only. DBI software has got an x64 version, but it's using the same engine as the web browser control, so it has the same deficiencies. And there is one, there's an Ant x64 browser that you could consider moving to if you don't want to stay with this one. But it works in x86 and x64, and I've stayed with it. So that's a good option. All right, so the next one is the common controls. Let's just briefly go back to the PowerPoint presentation. I've already covered which VFP am I running. Things that would work unchanged, as I said, native functionality, 100% compatible. So anything to do with manipulating your DBFs. ODBC, specifically SQL Server, MySQL, and MariaDB are validated to work the same. Actually, Microsoft has helped. If you remember, back in the day, 64-bit and 32-bit ODBC were walled off from each other, but now they are much better integrated, and you can utilize them seemingly cross-version. Commands that manipulate files on disk. The only thing I would add is that VFPA actually does this better than VFP9. So many here will be familiar with the problem where there's a momentary loss of availability for a file, whether you're creating it or updating it, and a split second later that is resolved. Now, whether that's caused by some form of caching or a virus scanner, it doesn't actually matter. VFPA allows you to decide how many times it tries to repeat that command before it gives up. And that means your application can continue without issue through any momentary outages. Quite useful, especially if you're using shared DBFs. All of the VFP GUI components, so the grids, all of those controls, interestingly also including Forms 2 and .NET ActiveX if you install the x64 version. I don't know whether anybody actually uses those, but anyway, they are compatible. Most Windows API is compatible. 6,000 functions validated so far, including all of the recorded Win32 API. The only difference would be that in the x64 world, any handles or memory pointers need to be expressed as long rather than integer. That didn't matter in x86 because they're the same thing. They're both 32-bit integers. But that's not the same in the x64 world. That's covered in the paper. You're using MSXML? Good news. Download and use the 64-bit version. And most COM functionality you've already seen. Not only can VFP x64 utilize 64-bit OLE automation, it can also use 32-bit. And the trick is that's out of process server automation. So if you're using an out of process server like Word or Excel, Microsoft has rolled an x64 wrapper around it so that you can actually utilize x86 resource after all. And Microsoft's not the only one who can do it. If we come back into my browser here, it's been known since at least 2017 how to wrap a 32-bit DLL so it can be accessed in 64-bit code. But don't get excited. It's actually a huge undertaking. And usually the conclusion is it's actually quicker to recompile the DLL into x64 than it is to try and render it. But what it does mean is that it's not that x64 can't utilize x86 resource. It's just that it doesn't. Okay, so there's the mystery solved. ActiveX, I mentioned the web browser. It's available by default, thoroughly proven. Microsoft Common Controls is the mission. We'll come back to that. Foxy Previewer seems to work, so that's good news. Now, GoFish, we're going to come to this. GoFish needs a Common Controls TreeView. So unless you've got a 64-bit Common Controls installed, you can't use GoFish. And even if you have got the 64-bit TreeView installed, it's unstable. So what will definitely need work? It's driven by the x64 can't access x86 resources except when it can. So FLLs are x86 by definition because VFP is x86 or has been till now. If you've got declared functions in x86 DLLs, unless there's an x64 version, you can't use it in practice. x86 ActiveX controls can't be used, and any other dedicated x86 resource can't be used. Examples. I use this tremendous resource, QR codes for VFP. It's using an x86 DLL for which there is no alternative. Barcode library.dll. Now, newer versions of the system allow you to use a different DLL, but it's still x86. And the latest version allows you to use the Google Charts API, but unfortunately that breaches a lot of security things you're not supposed to pass. Potentially secure stuff across the internet at all, let alone to third parties like Google. So basically, you're in a bit of grief if you produce QR codes in x86. The challenge as to whether you can persuade vendors to recompile their DLL for x64. And in some cases, that's not as much of a challenge as you might think. So, as you know, Fox Tools and FD3, which is the documentation FLL, and the Wizard FLL come with VFP. Those are converted to x64 and are installed as part of VFP x64, so they work unchanged. The only known departure is that the Fox Tools doesn't have regfn and functions like that, which were used before the declare command was made available, but I think everyone uses declare. If you don't, change to it. People have begun compiling their VFP FLLs for x64. So you can see these ones here. That Fox Pro user group FLL, which by the way includes some compression functionality. This DLL, which includes a huge amount of functionality, and FXRX, of course, which is a commercial XFRX rendering engine for reporting that works at x64, as do these DLLs. So people are starting to move towards the x64 world, and over time, more and more compatibility issues are going to reduce. All right. Let's have a look at some other issues. I talked about the TreeView. Now, on my machine, I'm in x64 here. I have the TreeView control installed. And if I run this form, which has got it's got a little bit of code in it to populate the TreeView. If we run it, so you get the idea. That's the standard TreeView, and it works just the same in VFP9, as you'd expect. So how did I get the 64-bit common controls onto my machine? It's a mission. So the bottom line is that when Microsoft began moving towards x64 product, there was no x64 common controls. It didn't exist. And largely, I suspect, because of access developer complaint, Microsoft produced an x64 version of the common controls in 2017 and began to distribute it with access and newer versions of Office 365. So if you can be sure that your customers all have access or a recent version of Office 365, then they will have MS-Comm-CTL on their machine. If only it were so simple. Just because it's on the machine does not mean it shows up in this or any other IDE. And normally what you'd do is you'd run reg server 32 against the DLL. I won't do that because it takes time, but if you did that yourself, it invariably throws an error and doesn't register the OCX properly. And that means you've got to run an actual registry edit in order to get the TreeView to show up in this or any other IDE. Now, in the files associated with my presentation, there's a .reg which appears to work for VFP to make the TreeView control show up in your 64-bit IDE. So if you can get the 64-bit version of the OCX, you actually can get it to show up in your IDE, and you can use it in your forms, but you've still got to get it onto your customer machines. I'm afraid you can't distribute it the way that you did the X861. It's licensed differently. And probably the best way to make sure a customer's got it is to install the Access runtime. There's a link to that in the paper. But even that's complicated depending how they installed Word or Office. It depends where the OCX goes. So monstrously complicated. I've got it going on my machine. I wanted to show you something. So there we go. It's just showing it to you. Although the OCX shows up in the x64-bit product, it's not very stable. And Mr. Chen is aware of it and has made some improvements to it, but doesn't regard it as a priority or as a tremendous priority. I would agree with that. If we look in the x86 world, I didn't know this, maybe you do, I didn't. There's an RC6 movement in the VB6 world, which is their way of uncoupling from MS-COM and assuring they have a path forwards. So they have it harder than VFP. They've had to uncouple their reliance upon the Microsoft user interface, and they've gone for the Cairo framework in order to generate their GUI. And they particularly don't like the Common Controls DLL. Well, now we know why. It's not very stable as you try and move forwards. And they have it worse than us because they've also had to decouple their reliance on the JET data engine. So they have a mostly ADO compatible wrapper around MySQL. I beg your pardon, SQLite. And what they're angling for is that in the AI days, they're angling towards a VB compatible compiler, which will allow them to produce binaries that are not any more reliant on MS-COM at all. So I think uncoupling from common controls is a very common motive, and my recommendation is to do that to the best extent you're capable. Now, in my case, even before the x64 version of the common controls became available, I had concluded I needed an alternative. And this is what I did. So we have this TreeView control here. And sorry about this. I just need to do a different set default to. There. I'm just going to change the set default because this thing is using images that I found out this morning weren't readily available. So when I run this, which we're seeing is a TreeView control, And this works exactly the same in x86 as it does in x64. I don't know whether you can see it's got nice little features like the opening and closing folders and so forth. So what is this? And no, it's not one of the commercially available options. It is, we look at base class, that's a VFP grid. And since we've confirmed that VFP native functionality is 100% compatible, you can be quite confident that this is going to work the same in x64 as it does in x86. So I guess some of you now are thinking about this, and you'd think the way to do this is to have a number of container controls in the column, and then you just use dynamic current control to display the one that's appropriate for your current situation. But I think if you look at it, the fact that you've got the expander controls showing or not showing, and this image here able to change, and if you look on the white paper, there's actually quite different icons can be shown here. You would need quite a few controls if that was the way you were doing it. So if we have a look, there is only one control in there. Some of you know how I'm doing it. It's utilizing backstyle underscore access. So many of you will know backstyle underscore access is an access event which happens to fire at a very convenient time during grid rendering, as it allows you to make changes to what's being displayed which render correctly in the grid. So basically, in this case, the control's got two images and a text box, and it just moves them. And it decides whether the image is visible or not. So pretty straightforward. It's also got an access property on icon picture. And if we have a look at this one, it starts to give you a clue how it works. If the node is expanded, it gives you a folder open. If it's capable of expanding, it gives you a folder. Otherwise, it gives you the icon picture. So you have complete control over what's showing up in those icons. Now, where's that coming from? I think you can probably figure it out. The way it works is this is all cursor driven or view driven. It can be a remote view. If we look at the load here, what I'm doing is I'm creating a very simple cursor, a title and a code, and whether or not the node is active. So that one's inactive. And then if you have a look at the class, it's got a source cursor property, which is set to that. And the class actually takes your source cursor, adds an lexpanded and lexpand and certain other metadata, and that's what causes it to display. And that's all done with the setup record source method. And you've got a late bind method. That's because you may not know what the source cursor is until the init event of your form. As we know, the init event of the form fires after the init event of the class. So late bind means it doesn't try and do anything until you specifically call setup record source in the init of your form. And edited is a flag you can set which actually causes any changes you've made in the display cursor get propagated back into the source cursor. So that's quite useful if you're using a view and you've got a form which changes values in this display cursor. Those propagate back into your source cursor. And everything else to do with the tree view is remarkably easy because the selected node is, of course, the row in the cursor. So pretty straightforward. You just read it off the cursor. The name of the cursor by default is random, but if you need it, you can set that to your own value, and that will be the name of the cursor in this class. So pretty straightforward. So let's have a look at a few things. Will GoFish work? Let's find out. By changing that default, I may have made it inaccessible. Yeah. GoFish, if we go into here and run GoFish, as you know, GoFish has got, this is a tree view control, but it's a very simple tree view. I'll just see if I can cause it to come up. What's it looking at here? A few bits and pieces. Well, that's a simple tree view. It hasn't got any images. So it would be a very easy grid, easy tree view to replace with this class. If people wanted to make it more transportable. As an example of the other things you're going to grapple with, if we go back into x64, useful functionality like class browser, boom. Now, why is that happening? If class browser's got a tree view and I've got the tree view set up in my machine, okay, well, class browser has also got it's got images in the tree view, and that means it needs an image list control, and that registry set of commands that I've run does not include the registry commands for the image list. Now, there are people who have managed to get the registry going for the image list, and they've managed to get class browser working in VFP x64, but you've still got that stability issue. So my decision was to move away from it. If people are interested in this, it's a very simple class. We could maybe add this in as a VFPX project so that clever people can spot all my mistakes and go ahead and fix them. But this is widely used in my systems and works in both x86 and x64 and has done so for years. So that's not a bad option. It doesn't have all the functionality of the common controls one, but it has most of what VFP people are going to use. All right. I'm in the x64 version. Now, this may not work because I've changed the set default. It's going to the wrong one because of my set default. So what that's showing you is it's VFP x64 trying to run an x86 version of FoxTools. So I've just fired this up and left the default as the standard one, and all of your functionality, as you'd expect, is available. So all you would do is you distribute the x64 versions of FoxTools and all of your functions, apart from those ones I mentioned, the ones that nobody uses, regfn and stuff like that, can be utilized. So if you've got, say you've got something which runs on a server and processes messages. So in the healthcare world, it might be an HL7 processor. Unless you've used dedicated x86 resource, there's no reason why you couldn't compile that into x64 tomorrow and offer it to your customers as an option, which starts to give you that flavor of modern development. You're pretty cool. You can offer both, like Microsoft does. So that's always a possibility. Now, here we go. Now you start to run into the issues. So this is going to be very familiar to a lot of you. Sweet Potato Software, Craig Boyd, released some incredibly useful FLLs to the community, gifted them to us at a time when trying to do it yourself using the Win API, for example, was actually extremely complicated. But it's x86 only. It's from the unsigned era. The website now redirects to Google. I think we can say there's not going to be an x86 version. There are other versions, Chillcat. Oh, excuse me. That Fox Crypto NG is actually produced by the same Christoph who presented earlier, and it's a wrapper around the modern Windows bcrypt API. But all of these other solutions require different syntax and parameters. So you would need to refactor all of your calls to VFP encryption.FLL, and that becomes a barrier to progress. Now, I do use VFP encryption. I used it to do things like de-encrypt connection strings for SQL Server and other uses like that. Anything which needs to be transmitted ought to be encrypted. So I had a problem moving to x64, but actually Christoph helped solve it with his Fox Crypto NG. And what I did was I developed a VFP encryption FLL.prg as a drop-in replacement. So let's have a look at that. To use my procedure, you set VFP encryption that's all you do. Rather than set library to VFP encryption.FLL, you set procedure to vencryption FLL.prg, and now works the same. So hash is a VFP encryption function. If I now go into VFP 9, set library to VFP encryption.FLL. Whoops. If I take this fella, go over there and execute it. Whoops. Okay, so if we look at it, it's got a sort of an EE type thing there, and it ends with a upside down question mark Y. And we go back into VFP x64, you've got the EE upside down Y. You can validate this yourself, but they are exactly the same. At least hash is exactly the same. Now, unfortunately, the FLL has got a problem, and that is one area in which the program is not compatible with the FLL. If we encrypt a string, a short string in particular, so I've just used the defaults, and if we look at the length of that, it's 32 bytes long. That's actually wrong. The AES specification says that block length has to be 16 bytes. And when you're encrypting, you're supposed to pad the string out to a multiple of the block length, which means this should be padded out to 16 bytes only. If we go into x64, that's using the PRG, it's a much shorter string, and it's only 16 bytes long. Now, I'm doing it manually so that you can see that x64 is working exactly as you'd expect in, in VFP. It's working just the same. So what I'm going to do is I'm going to convert this to base 64 binary. Did that work? So there's my base 64 binary version of the ciphertext. I now go into okay. I'm very sorry, it's closed down. I had a URL up here which allows you to decrypt AES strings. You can do it yourself. The one produced by this PRG is correct. The one produced by the FLL is doesn't decompile utilizing standard AES. I think it's caused by block length sometimes being set to 32 rather than 16 bytes. Now, the key length can change for AES depending on the cipher you're using, but the block length is not meant to change. And I think what's happening is the FLL sets block length to 32 bytes in some situations. And the reason I think that is because if you hard code the block length into here, if you look up here, I've already got some examples here. If I change that to hash me, I can start to show you. If I change this to and use parameters in the FLL, so I'm specifying a block length of 16, it's now down to 16 bytes. And if we look at it, I think you'll find that's actually the same as the one we had over in the x86 version. And that's achieved by specifying a block length in the FLL. So if you've been specifying block length in your use of VFP encryption FLL, then the PRG is completely compatible. If you've been using defaults, then it's possible that the FLL was producing AES that cannot be de-encrypted by either the PRG or other AES mechanisms. Now, if you have a look in the PRG source code, which is included with the files accompanying my presentation, you can see I've actually attempted to utilize bcrypt parameters and mechanisms to change the block length, but it won't let you. And that is because the AES specification states it has to be 16 bytes. So that's one area in which the PRG is not completely compatible with the FLL. Let's have a look at it. There's some credits at the top that I'm going to bring up now. This is relying heavily on Christoph's Fox Crypto ng.prg, but also on Dimitri's fork of that, which added the HMAC function. So just going through the source code here, I've tried to make it self-documenting. Where it doesn't have some ciphers or some options, the comments tell you. I think the big one in this case, there's two of the hash options aren't available. Those two aren't available. So I'm sorry if you use those, then you can't use my PRG. That's because bcrypt hasn't got them, but all the others are available. The big one is Blowfish. I'm sorry to say that bcrypt, the Windows bcrypt API does not contain Blowfish. So if you've used Blowfish, you'll need to find another mechanism. Can I suggest that we make this into another VFPX project so that others can go through and correct any mistakes I've made and add more functionality. Maybe someone's got an implementation of Blowfish that could be added into here. And the other difference is that the FLL does have one security problem, which is if you're not using parameters, it actually defaults to the ECB, electronic codebook cipher, which is regarded as insecure in 2025 and has been for some time, just like the MD5 hash has been regarded as insecure. Some of my customers contractually disallow use of ECB in software which is made available to them. The US government does too, by the way. So if you've used ECB in your FLL, you kind of need to think about going through and refactoring your code to use one of the more secure mechanisms. So that's the other area where the PRG differs from the FLL. If you specify one of the more secure ciphers, so if we have a look here, these are the encryption modes that are available. This is copied directly from the documentation for the FLL. ECB is the default. I'm sorry, OFB is not available in the bcrypt, but these two are. Your options are you can change the default to say CBC or CFB as you see fit. And then every call that you make to encrypt, if you haven't passed the parameter, instead of using insecure ECB, will start to use CBC or CFB. So that's good. But these ciphers these modes are regarded as more secure because they use an IV, initialization vector, which is a random string the same length as the block. So for our purposes, that's a 16-byte random block. And the way it's used in both of these ciphers is it XORs the first block. And then because of the way AES works, you've got randomization proceeding through the rest of the string. So your code is not providing an IV. What to do? Well, the PRG, if you've used one of these more secure modes and haven't provided an IV, the PRG creates a GUID, which as we know is a random 16-character string, and uses that for the IV and suffixes it or adds it to the start of the ciphertext and returns it. So that means that your source code needs no changes at all, and it's suddenly using a secure mechanism with a random IV. Now you might say, well, that's no good because you're prefixing the IV to the ciphertext. That makes it very easy for Mr. Hacker to know what it is. And that's true, but it doesn't matter. Cryptographically, the IV doesn't need to be secure. It just needs to be random. And you can go and look that up yourselves. But if you're not satisfied, this is VFP code. So you can make it obscure, add half it to the beginning and half to the end, transpose a few of the characters. It's up to you. You've got lots of options. So that is supplied with your the code that came with this presentation. Have a play with it. See what you think. So look, what I've tried to do is give you a run through utilizing the x64 version to a reasonable extent, showing you that it's not as much of a challenge as you might think, especially if you are able to end your reliance on ActiveX controls in as much as possible on FLLs, unless your vendor has made the decision to recompile them for x64. So I believe I'm running towards the end of my designated time. So what I've covered today, you can install the VFP add-on very easily alongside VFP 9. Make sure you've got the correct version of VFP 9. Turn off that setting that I showed you in the installer. Away you go. Native VFP functionality, 100% compatible. It's not possible to show that in a just over an hour presentation, but I've tried to go through and show you myself using the IDE a bit and getting the same sort of errors and the same sort of behaviors as you would expect in the x64 version. Web browser and things like Word, Excel automation work straight away. Doesn't even matter whether you've got the x64 version of Office, it still works. Some important FLLs are available. Some that aren't available can be replaced, such as using that PRG I showed you, or that TreeView grid I showed you, and perhaps vendors can be persuaded to recompile for x64. They may not want to test it, but maybe some of us are happy to test it. And my overall theme would be decompiling from ActiveX is a worthwhile goal. It doesn't really matter which version of VFP you're using. ActiveX is regarded as obsolete in the modern development world. You want to try and get away from it if you can. The last thing I would say is sign your work. Now, we all came from an era in which not even Microsoft was signing its work. So as a recap, the VC++ 7.1 runtimes used by VFP and the VFP runtimes themselves are not signed. If you move to x64, the VC++ runtimes are signed. And I now routinely sign everything that I distribute to customers, and you should too. That will help you pass any security audit. It's also good practice because it means that a hacker cannot use your system as a vector to inject malicious code. And we're kind of out of time, but if people are interested in the question section, I can show you one other mechanism that I use to make my stuff extremely modern, and that is VFP C++ compiler. But I'm pretty sure that ends my allocated time. So thank you very much, everybody. I've tried to run you through any misgivings you may have had about x64 breaking your VFP 9 or being difficult to install. A few preparation steps will cause it to fly onto your machine. It doesn't need to stop you working with VFP 9 unless you choose to let it do that. And I can stop there unless people want to have a look at this